this for the moment being. I'm going to show you some of my vacation slides now, just so the guys can catch up from now in Cebu. No, so I like to go on site and visiting my clients, like I am right now, visiting the free program. So this is in Australia. This is where the FUSA data set is from. This is a LiDAR aircraft, a very lightweight LiDAR aircraft. It's a glider. It uses only 3 liters of regular gasoline for per hour flight. And in these pods, it has one pod is for a scanner, a LiDAR scanner, and the other pod is for a hyperspectral scanner. And ECB, and then we take off. This is in Adelaide. Before Chris talked about flight planning, this is flight planning. So we want to cover this area here. This is our target square. We want to cover it with double coverage. The Dream team doesn't do double coverage usually because usually you can achieve everything you need with one coverage, unless you want super high density. But we just wanted to, it was a very small area, so we wanted just to get a very high as possible resolution. So we flew around. That was the center. This is all the eucalyptus trees. That's a little solar panel house in the center. And then we got back to his solar panel house, and then we used LAStools to cut the last boundary. And then you see one of those command lines. You know, this is how these things look like. It's not that scary. And we turned some of the solar energy into, remember when I started out asking, how many of you know how to make a boundary around the LiDAR file? And the shape file it says here, but this is a KML file, it's just as good. Well, that's more or less a command. Now you already know it. Well, we'll do it then you already know it. So for all of the strips we've flown, we make quickly a KML file. And the command just, we can come back to that, so don't freak if you don't understand it. -I, that means that's the input files. This is a folder called Kumaracha because the town of Kumaracha is over there. Star.laz, that means every file in that folder that ends with .laz. Those are the compressed LiDAR files. For all of those, output the KML file and put it into a directory that better exists. If it doesn't exist, it will crash. It will error out. The directory is just called KML. Should maybe be called Kumaracha, outlines or something like this, but then it wouldn't have fit on that slide. Here's another example. How can I make very quickly hill shading? Well, that tool is called LAStools. So LAStools is a tool that makes hill shadings. Also the DTMs and the DSMs. So I take again the Kumaracha LAS as input. I see a step size. That's how big are the pixels of the image. One pixel is 2.5 meters on the ground. So I make one pixel with 2.5 by 2.5 meters. And in this case, I use the last only. It's a last only, a last return DSM. I do some thinning with the grid. I'll maybe go into that later. Why? I make a hill shading. So if you make a hill shading, that means you're not creating actually a DTM you can use in a GIS package. You're creating something for the human eye, a hill shading. That could be, and we output it to a different directory. The directory is called hill shade in the PNG format. PNG is for images. Hill shades are images. And it will do it separately for each one of these strips. So these are all individual images now, and I only show you the east-west flights. So these are now 8, 9, or 10 different images. This is just a quality check. I'm not really producing the DTM, because usually you don't produce a DTM or DSM for just one flight line. You may do that for quality checking, for quickly looking at your data. For example, when you put it into Google Earth, you can then quickly see the roads in the LiDAR aligned with the roads here. Now that's not a rigorous quality check. I would more call it a sanity check. Because you shouldn't think that Google Earth is the truth. You know, Google Earth is a very useful tool. And I'm very happy to see that the roads align everywhere here because it gives me confidence that I probably did the right things when I set up, you know, when the other team, the team of Joyda that produces for the Dream Team these glass files, set up the projections and the foresight angles and all this complicated stuff correctly. But I also see here that there is a gap in a gap in coverage. And I remember, and I probably we'll be seeing this again when we do real quality checks tomorrow for the LiDAR team, for the Green Team LiDAR data, that they were just flying with not enough overlap. Or maybe the pilots must be boring, 4 hours flying back, forwards, backward. The pilots were listening to music, you know, and they go like, Gangnam Style, you know, and then the airplane, of course, you know, there's a LiDAR attached to it, a huge movement on the floor, so it needs to listen to more calmer music. And then there's a tool to actually check for this overlap. Do I have enough overlap between my flight lines? That tool is called, well, last overlap. You know, again, I input all these flight lines. Now I make it more detailed. I make a snapshot of 1 meter. I tell the tool my files are flight lines. So each file is a separate flight line. And then I put it into one big overlap image. And that image now, which you may think, I want a print of that and put it into my living room. That's beautiful modern art. Right? Yeah, I'm selling them after the course for so this beautiful modern art also has a meaning. Blue means it's covered by one flight line. Oh, I never used that. But I'm screaming so loud, everybody can hear me, right?
Yes.
Okay. Agua is 2 flight line coverages.
Yellow.
3, 4, and 5. So now you see the east-west strip wasn't covered properly, and the north-south strips, which we could have hoped, maybe they closed the hole. They almost closed the hole, but not quite. Now, and if this happens, you don't have information there. The only way to get it is either you send somebody out there with a total station, and he's going to spend like a weekend getting all the points, or you send the plane back up. But that's also very expensive. Or you just leave a hole. That's most likely what's going to happen. So that's not nice. So good flight planning and calm music while you fly the plane is important. It produces another raster that shows you the differences between the flight lines. In this case, it's very, very bad. It shows you the differences in flight lines because, remember, we fly several times, and the flights are, you know, there's a few minutes, an hour later maybe, and there's a lot of mathematics involved. So there's IMU that measures in the plane how the plane is rolling, how it's pitching, and how it's, the direction it's going. And there's the GPS that tells me the position, and then there's a lot of mathematics I need to do in order to get the points. So how could we possibly assume, after all these potential sources of errors, these flight strips will fit together perfectly? The house that's in one strip is at the same place where the house is in the other strip. And that they're maybe not like just 2 meters apart from each other, which would make it very horrible to merge them into one file. And that's what you check with this one. It colors based on a max difference value that you can set, and that's, usually you don't set 2.5 meter, usually you set 20 centimeters, so, oh, somebody's nodding over there. And that shows you the differences. In this case, the differences are horrible, but that we generate this data set on purpose. That was actually part of the exercise, to have a very bad data set and to see if we could fix that eventually. I still haven't gotten around to doing it. by afterwards shifting the flight lines all back into the right place. Another tool is called LASGrid. LASGrid can do many different grids: intensity grids, color grids, height grids, and it can also do, a density grid you see here. So it just counts the total number of points falling into every 1 by 1 meter area, and then colors them with the false coloring going from blue to red. And the false color for blue is 0 points, and the false color for red is 100 points. So if it's at 100 points or more, I make it red, otherwise it's blue and everything in between. And then I'm using all the points, so you see clearly where we have vegetation and flight land overlap, we get very high number of points. I usually don't create this particular thing because it's not particularly useful, but we get to that later when we do the holy checking. Now the holy grail is last ground. Somebody asked it before. This is the last returns, and this is the ground returns. This is much more useful than this if you want to do flow modeling of water, because water, that trees and everything's still in there. So you really need to know which are the ground points. It's impossible to be 100% correct unless you go through every point manually and figure it out. The algorithms are fairly good. They make mistakes, and then you have some manual post-processing. But once you have the ground point, there are 2 more steps you can do to find building points and vegetation points. In LAStools, these are called last height, which computes the height of every point above the ground. Like this point maybe is 3 meter 89 above the ground. And once I know this, I can then figure out where are planes above the ground that are as high as typical buildings are, and then I find the roof planes. And even the solar panels, you can see. Yeah. All right, I don't want to go into this anymore, but I want to start you guys on some actual LiDAR processing now. So, I think our traffic-induced latecomers may need some special assistance. So make sure that the charm helps you. Everybody else, the first tool we're going to run now is called Last Ground. Last Ground. It's right here, and I'll double click it. It's always good to check, am I using the right tool? Always in the top it says what tool it is. No surprise here, I told you the left side is always the same. So before I go over to the right side of the tool, let's load the file I want you to work with. And today we're not doing any Philippine data. I still have to review which data we're using tomorrow. So let's go to, area 2. Yeah, it's area 2. So again, if you just went to browse, you see this area 0, 1, and 2. You double click area 2, and there's one file in there, tilesmall.laz, and you double click it, and the same boring thing happens like last time. You get blue. Who thinks this is blue?
Science.
Science? Who thinks it's green? It's blue-green. Okay. Now, a useful thing to do is when you get a new piece of data, just view it real quick. I press the view button, it's part of every LAStools, and then I'm pressing start, and I'm viewing the LiDAR data. So it's a forested scene. I'm pressing X. I'm making a little. I'm pressing X again, and I have a little forested area. Now I can walk through this forest. Here you go. I can change the colors. Now you see many more green now, many more intermediate returns, because we have much denser LiDAR scans. I can look at the last returns. These are the last returns. They are not on the ground. I mean, there are many of them on the ground, but there are even more of them not on the ground. Even the last of many are often getting stuck in the tree. And these are the first returns. First, last, first, last, first, last. Okay, this is just a quick check to show you. And when I go to classification, color by classification, they're all black. This is not classified. So I don't know what is a ground point and what not. I press escape, and then I'm back at my, don't press escape again, only once. If you press twice, then you have to go start last round again and load the tile again. So now I'm having a look on the left side, and I'm setting the options for my particular last round. I think I will have a problem because I won't be able to run mine, because the run button is fun. This will be challenging. Anyway, first off, this is a wilderness area or nature area, one of these two. I would put wilderness. This means how subtle of a detail of things on the ground are picked out. There are no houses in this area. If you had houses, you need to go to a bigger area, otherwise the houses are remaining inside the scene. So in this case, let's pick wilderness. The settings here, you can leave it at default or make it in fine. This is the amount of pre-processing you do. If you choose metropolis or something bigger here, then you should put it on ultra fine. Ultra here. But for these, read the README file. Or we'll get into that more later, what these options, how these options can improve things. We can name the output. There's a very easy way of naming the output file. I can either give it a file name, or I could put it in a different directory. But the easiest thing is, especially if you work on just one file, just give the file a new appendix, like G. And just put a G here, and it will take the old file name, tile small, and add a G to the end. I think I'm done here, but I would like to press run now. I don't know how. Does anybody know how to create a virtual bigger screen which I can scroll around on? I think I did that once, but I forgot how to do it now. How can I move? Well, okay, I think I need trick. I need to do a trick now. Alright, everything you do by you get done by the API. I must now type myself. Then I put it minus fine, minus O dix. If the G is enough, if there's no space in there. Oh, by the way, don't ever put a space in a file name, or don't ever put a space in a directory name. It's a very bad practice. It was introduced by Microsoft. Nobody did that before, and then Microsoft called it My Documents, My Space Documents. No, it should be My underscore documents and program files. It should be program files. A lot of programs don't work. Need to, yeah. Don't put spaces. And no funny characters. You know, like in Germany we have like umlauts. You know, characters with 2 dots on top. Like always 2 dots. I would never put that in the file name because computers have limited number of characters, and you need special things, yeah, to handle the special ones. All right. So I think you should have this. If you press run, you should have more or less this. Last round, the input file is the area 2 tile small. We run in the option wilderness, and there's fine somewhere. I think you have this in brackets. I don't have it in brackets. The bracket is only for the case that somebody put an appendix with a space in there, which. And then minus O LATS. That means the output should also be compressed. It should be output LAZ. And how to remember this? Output appendix. ODIX. Output appendix. It's really just like stenography, you know, like short, almost like an English sentence. Right? I mean, before, you know, when Sir Louis and Sir Chris were talking, I don't know if you noticed, but they spoke half English and half Tagalog. And I sat there in the back and say, I can sort of understand it, you know, but then I have to interpolate, like, sometimes an entire sentence, and then I understand it again, and then interpolate. So it's almost like that, you know. So, now I press. So now it's also a way you can review your command line. You can review once you understand the command line, you can review if your menu settings make sense. And then you press start. And now it's running. If you look for the black window, I did that with pressing Alt-Tab. I can see actually what it's doing because it's outputting what it's doing. By the way, I don't know if many of you noticed the trick. I was using last view. I pressed the view button. And then I edited it to last round. So I completely changed the command. I had to do that as a trick because I didn't know how to otherwise do it. I couldn't see the run button. And it will tell me that the command was manually edited, new command, this is the one I edited, it's processing it, and it's done. Mine took 27 seconds. Who is faster than me? 27.4? Wow. Anybody faster than 27.4? Let's see. 26. It's a little clearer there. Tiny screen. 26. Big computer. What's there faster? Anybody 22 or 20? No? 22. 24. Wow. Nobody better than 24? Okay, so 24 seconds to classify a file with 3.5 million points. Okay. We can now quit last round. We don't need it anymore. You can quit it in many different ways. Just by closing this one, it's a half quit. Quit. So it's gone. It's not safe, but you can, well, I can't save it anymore.
At the beginning, you put it like when you're at the
I could have saved it before I closed it. Manually by just copying and pasting it. I don't have an automatic logging right now. I hope everybody got there. If not, look at your neighbor, because today is not so crucial, because today our pipeline is very short. Tomorrow it's going to be more crucial that you get every step along the way. If you couldn't do it, maybe call Charm and she'll help you. So now I'm looking for a new tool that is called LAStools. LAStools, LAStools. Double click. And it should say exactly what mine says. It's raster LiDAR. And here again, by a temporary tint to a lot of different things. So now I say browse. I go again to area 2. And surprise, surprise, there's a new file. I hope you also have a new file there. Small g. G, that's the ground, hopefully, ground classified file. So I'm double clicking this time, only this one. And it shows up here. That's the one I have loaded. I haven't really loaded it, but it's in my project. I'm closing this now. So I want to now raster a ground tin. Oh, basically, first let's look if that worked. For this, it's always good to check results, check intermediate steps. So we view the new file. Say start. And wow, we got ground points here. This should give us some grounding points. Yes. So it's ground classified. If I press G, all the trees disappear. And if I press X and look at the little intersection, I press X again. A like all points. And yes, here the ground points, all points. Okay, I got the ground points. I pressed escape to go back to LAStools. And now I want to create a DEM. Actually, this time we're not going to create a DEM. We will create a hill shaded DEM. And I would always like to remind you of the difference. A hill shaded DEM is also a DEM, but it's just an illustration of a DEM. A DEM means a digital elevation model. That is like an image where every pixel is the elevation value. So it says like, 111 meters, 17.53, and so on. But that's nothing you can really easily look at. You first need to shade it somehow. Hill shading is one of the ways you can shade it so it makes sense to the human eye. But then it's no longer a real DEM, it's a hill shaded DEM, it's a visualization of a DEM. But that's good enough for today, because it's basically the same computation, just a different output. So, instead of, so let's go systematically through it. We need to filter now. We classified the points into ground points and non-ground points. That's what last round does. We have ground points and black points. Ground points are the ground points. Black points are, we don't know what, but it's not ground. When we want to make a DTM, we only want to use the ground points, because a DTM is a digital terrain model only using ground points. So we now filter, keep classification, and we must say which classification. And now there's this one thing, well, there's a few more things, but this one thing you really must know is that number 2 specifies a classification class that is ground. And then you press add, and I don't know if